So, the reason I've brought you all to this precarious perch is we need to talk about partial derivatives. Okay? So, down here, let's see, where's a good function? So, I'm going to envision this part of the rock as my level or as my function, okay? You guys all buy that's a function of x and y giving you a height?
Sure.
Why not?
Okay. I'm going to put an x and a y axis someplace, kind of at random. So if I look down from above, right, that'd be an x and a y axis. Which one would be which?
That will be x
That's
and that
actually
will be y.
Doesn't really so much matter, but to keep the right-hand rule going, right? X, y, and then my positive z points straight up, right? Okay, so looking at this chunk of rock here, I'm trying not to fall down the hole. Okay, I see that there's like rates of change here, right? I definitely see that from Calc 1. Okay, see some of those? But if I was thinking, okay, like here I am at this dot. I've got kind of an x direction and a y direction, but what rates of change can I see from here? You see that? Like if I was standing on this dot, what could I see?
We're going up this way one way and then
Yeah, there's, so in the z, right? So I'm thinking about what's the rate of change of height? Well,
by x or by y.
yeah, so let's see, there's roughly a level curve, right? Along that direction, what's height changing at? Hopefully it's 0, right? Because it's a level curve.
Yeah.
You guys see that? Where's the steep way from there? Yeah, like straight up this, right?
Yeah.
Uphill. There's also a steep way the other direction, right?
Yeah.
Downhill. Okay, so I need some way to organize this information about uphill, downhill, and that business. So the first thing we're going to do is we're just going to say, okay, I don't know how to do two-dimensional anything, right? But I'm pretty good at this point at one-dimensional calculus, right? You guys all should be pretty good at one dimension. So let me make a slice. Let me say, okay, in the x direction, right, that's like this way. There's some function here. You guys see the height function in the x direction? That should be like this. Can I differentiate that function? Do I know how to take that derivative? What's that going to tell me about? Yeah, that's going to tell me the slope in the x direction. That's going to tell me what kind of a tangent line I would have right here. You guys see that? How would I get that? Like, what would I do? How do I make that slice?
Slice the z.
Yeah, I want to make a slice in the z.
Z-y?
Z. Which one is it? Is it z
Yeah, ZX.
parallel, right? Because I want to take a plane that's right, running through the x and z axis, and then kind of think about offsetting it, right? You see that? So I've got a slice parallel to the zx. How do I get a slice parallel to the zx? Yeah, it's set y equals to whatever the whatever the y coordinate at this point is. So that's me looking at this and thinking, okay, y is some constant, right? That's going to give me a function of one variable. I can differentiate that. I know how to do that. How would I do the other direction? Yeah, it set x equals to a constant, and I'd get some function going this way, right? And then if I took a derivative, what would the tangent line there mean? Or what would that slope mean? Yeah, the rate of change when I'm changing the y variable, right? You guys see that? So that's all we're going to do, right? And that's really our first step. That's all a partial derivative is. We're going to treat y as a constant. We're going to get an x derivative. We're going to treat x as a constant, and we're going to get a y derivative.